We want to be free to ride our machines without being hassled by the man.
So before I start buttoning this thing up, I thought I'd look at this capacitor after going through that reforming process. And 100 kilohertz, 100 hertz. So there it is, 9.15 millifarads, 0.1 ESR. If I go up to 120 hertz, yeah, 9.2.1. So, you know, it's within 8%, yeah, 9%, 8.5%, whatever you want to call it. Yeah, there was. So the other one reads 10 millifarads, 0.1 ESR. So I think they're pretty good. And just so you know, I dropped it. Basically, hang on a second. Sorry for the camera thing. I don't know if I can edit that out. I'm dropping everything. To get the capacitors out, I used the socket wrench. Use the socket. I'm dropping everything. It's with the screwdriver. Yeah. Yeah. Also, I looked for a macro. Went through the menu on this camera looking for the macro. I didn't see one, so put the Phillips head in the quarter-inch socket and do it that way. Otherwise, you never get a screwdriver in there. But this is good. So back we go. Back we go. So also, just as a side note, you know, the reason you remove the positive wires and the negative wires that are all the way down at the bottom, so that your power supply, when you're reforming the cap, you don't backdrive the amplifier, especially one-sided. Notice that they have a strap between the plus down there and the minus here next to each other, and there's a strap between them. So you got to remember, when you take the negative side off, that's the negative side. If you're reforming the cap, you know, if you don't have the cap right in front of you, you got plus minus, remember, you're using a positive supply. So that means ground is positive. So hook up your positive to ground and your power supply ground to negative side, so that you get the right polarity. Otherwise, you're going to try and reform it in reverse with a negative voltage, and it's not, capacitor is not going to like that, especially if you do it with if you don't do it slowly like I did, or if you do it in chunks and don't start out at a low voltage. If you just put 100 volts with a 100K resistor or something on there, and it's in reverse, it's not going to be good for the capacitor. So I just wanted to point that out. This top side, they put a tooth washer on the inside there, And getting that tooth washer on the inside with the nut screw down on the bottom is pretty difficult. So still working on that. It's a heck of a thing. Okay, I've got this back together. These knobs aren't accurate. They're just kind of stuck on there so I can use it. Interesting thing is, when I was cleaning the switches and the pots, I could rotate the pots real easy with my fingers. Once I got the panel installed, they're really difficult to turn. It's because they have, each of these have a little plastic insert bushing, and it acts as a dampener. So these feel pretty good. They're dampened. They're not real loose, but you can't turn them. I got to put the knobs on in order to turn them. And so I've got this back together. Got the two boards in either side. Get all the wires tightened up. Interesting thing is, in order to check the bias, they want you to remove the wires and put a, well, either put a clamp on the wires, current clamp on the wires, or disconnect them and put a meter in series with them so you can adjust the bias. So we'll see about that in a while. Right now, you see I've got 120 volts and 60 hertz. I've got my light bulb connected. I've got a meter over here for this channel, check for offset, and this one on the other side to check for offset. So we shall see what happens here. Yeah, inrush current, the bulb lit. That's good. There goes the relay. And we have 115 volts, 41 watts, almost half an amp current. 0.8 power factor correction. It's pretty good. So what do we got? We have the offset voltage is supposed to be 3 millivolts, plus minus 3 millivolts. So we got 17 there, we got 19 there. So, and there's the meter brightness. So it seems to be working. Let's see, is that dropping? That's not dropping. Let's try. So there's the brightness pot I installed. Clockwise would be brighter. Let's see if this works at all. This camera may not show it. It's going dimmer. It's definitely gone dimmer. Probably can't tell on the camera. I don't know if it's quite as dim as I would have expected, but it's more of a dimmer yellow light. Let me turn it back up. And now it's getting a little brighter. Yeah, definitely getting brighter. It's going more towards white. Typical incandescent white, not pure white. So that's there. Sort of working. And that's gone down to 12. That's gone down to 14. So that's dropping. Interesting that yeah, this is 114 volts now. It's probably, I think, yeah, the bulb was getting warm, so I'm sure the bulb was dropping some voltage here. 5 volts. So let's try this again just for the heck of it. Turn it off. No current draw. Over here. Boom. There it goes. 114 volts. I've got about 10 millivolts and 12 millivolts on the meter. Oops. I suspect I'm going to keep dropping voltage here. So I need to get rid of the dim bulb. Everything's working. I'll try it without, well, yeah, I'll try it without the dim bulb. Leave the meter connected. Nine and a half millivolts, 10.5 millivolts. So it's warming up, and and the offset is dropping. I have it in a dual 100% mode right now, despite what this looks like. I think the best way to put the knobs on is to set the amp down on its back, so you're looking at it this direction downward, and then you can adjust the knobs where they need to be and tighten them up, because they have, a couple screws and they're not in the right position when it's sitting on a bench. This is the big knob. I was talking about putting a smaller knob on originally. But it tends to stick out a little bit. And this one's actually it's the same knob as these other ones. It's just a little bit bigger. So generally it fits better. There it goes. Relay clicks. Let's check that out. Let's see what happens here. Give it a little bit to discharge. Okay, let's go. 0, 1, 2, 3, 4. Oh, 4 seconds. What happens if I do it fast? Same thing. Okay, I'm going to get rid of the bulb right now. Turn this off. Get rid of the bulb. And we'll start again. Okay, so I got rid of the bulb. And let's see what happens when I turn this on. We're sitting at 120 volts still. Power factor correction went down. That's interesting. So we're back to 19 millivolts, 14 millivolts. I don't know if there's any point in adjusting the offset if the bias isn't verified and adjusted. So what I'm going to have to do, I'm going to have to desolder a couple of these wires and go over to the power boards as the instructions indicate. And it should be set for 75 milliamps quiescent current. That's with so that's 70 to 80 milliamps, 75 nominal. So I'll have to get that set up. 15.8, 13.3. This will probably take a while to drop to 0, but at least the voltage is holding. 0.7. It's not as efficient. Oh yeah, see, now it's doing 49 watts at 0.7 instead of that 43 watts. 50 watts. All right, so we'll get those wires going. Okay, a few comments to make. I adjusted one side just because it's not trying to hold the camera and do this at the same time. But it was kind of funny because I was trying to adjust the offset. I have a meter over here. I have a meter over here for each side, assuming this is channel 2 and this is channel 1. And I was adjusting the offset pot, and the meter wasn't changing. So I figured there's something wrong with the board and the offset circuit. So I'm goofing around, and I decided to change this one, or just adjust this one, adjust the offset on this one. And I noticed the other meter was moving. This meter over here was moving. And then when I adjusted this one, this meter moved. I thought, so, you know, dumb guy, got the wires mixed up in the back. Well, I decided to follow some wiring around because I don't know what they're doing. And it turns out, yeah, this is channel 1, just like it says. This is channel 1. This is channel 1. But the output banana jacks for channel 1 are over here. So this is channel 2. This is channel 2. This is channel 2 with the output jacks. So this is the output jack sitting here like this. This is channel 1. This is channel 2. So in a sense, my wires were crossed, but not on purpose. Just misunderstanding where channel 1 is. They are marked on the back, channel 1, channel 2. So the other thing is, on soldering this wire, I thought, you know, it'd be nice maybe if this was a flying lead connector and you could just pop it apart, put your meter in there. I mean, it's kind of nice they have these lugs, these ring lugs with multiple solder points. I've never seen these before. I've seen like quick connects in a furnace that have multiple taps, but not a ring lug with multiple taps. And I was thinking, you know, a couple ways to do this. I could do a flying lead, which I really don't want to do. More connectors. I was thinking I could set the bias at 75 milliamps, do it this way, set it at 75 milliamps, and then take a reading across an emitter resistor, which actually kind of comes back here. I could do it on this channel. There's a 10 ohm here, and the common points over here on the relay. And I could get a corresponding voltage across that emitter resistor and do it that way. But doing it over here, all that stuff's way down there. You can't get to it. And this is kind of hokey too. So what I decided that I think I'll do is I take this off. I'm going to put a ring lug on here. Solder a ring lug, not crimp it. Solder a ring lug on here and then just, you know, put it back on the cap. And I'll do that with the other wire too, that way. And these are the only place you have to do it. These are right at the top. You take it off and you can do this real easy. You don't have to unsolder things. Not very often you have to do this. But for me or somebody in the future, maybe, might be a little bit easier. I'm going to put a note. I've been sticking tech information on thumb drives and putting them inside the units. You know, maybe put it like in here somewhere. And I'll put a note on the PDF that's included in that. So if anybody bothers to pay attention, they'll know in the future. They can just unscrew this and disconnect the wire and check the bias. So I'm going to put that on. I'll put that back on. I'll unsolder the other wire and I'll do the, I'll see if I can do this on camera with the other channel. One thing I noticed on this one is the manual says to go let it warm up for about 5 minutes. I think 15 minutes would be better, at least 10. because the bias current will double as it warms up. I've got this set for 75 milliamps after it was on for about 15 minutes. When you first turn it on, it's like 35 or 40 milliamps. And it takes a little while. The offset did go down, it did adjust down. I probably have it at 1 millivolts, so thereabouts. Spec is plus minus 3 millivolts. It's pretty tight. I'd usually say at least 10, but that's fine. Professional amplifier, right? Professional. Okay. So let me get this. I'm going to get these lugs on here, get this unsoldered, and then I'll try this again. Try and do it on camera. All right. All right. This has been on at least over 10 minutes. And the heck. And there's the bias, 70, almost 76 milliamps. Yeah, I put the ring lug on there. The other one's on there and attached to the capacitor, other channel. And I've got one. This started out about 15 milliamps, millivolts, and it's now minus 1.5, so I might adjust that a little bit. This is holding pretty good. It was at 0.5. It started out at negative 15 or 20, and that's settled down pretty good. So that's in spec. 70. This is still going up a little bit. 70. I didn't touch it, so it's the spec is 75 plus minus 5. Still going up a little bit. Who's beeping? Yeah, this one's really dropping. Alright, so this one is for this channel, and this offset over here, wherever it is for the channel 2 over here. So channel 2 is, see, it's changing a little bit. Oh, that's what the beeping was. The meter went off. $76. That's a 0.2 offset, millivolts offset. I don't know. I can see. Yeah, the offsets. You have to get in here with your fingers. Great. Well, I'm not going to do that with the camera on. I can't watch what I'm doing. But everything's pretty good, so, yeah. I think putting the ring lug on there so that can be easily separated in order to do this bias adjustment test is not too bad a compromise. And what I'll do is I'll get this set and clear this stuff off of here, and I'll get the scope and we can look at this brightness circuit a little bit, get some voltages. I don't know if I mentioned it, but I did measure the relay. It has 22.5 volts on it. So that's about 24 volts minus the Darlington SCR drop. Yeah. So again, this is 76. It's climbing up a little bit. I might drop it just a tad, but because if the thing were to warm up more, yeah, it might go up. That's not too bad. All right, meters are nice and bright. Yeah. All right, turn this on. Relay. I measured the relay. It's 470 ohms. It has 22.5 volts across it. So that's 48 milliamps. 48 milliamps times 100 ohms is 4.8 volts. That gives me 230 milliwatts. So that 100 ohm series, the resistor, 100 ohm resistor that's in series with the relay is dropping about 5 volts, 4.8. And here's the waveform for the lamp circuit. So you can see this is all, it's a full wave rectifier. It's going to about 34 volts. The relay, which is half wave, would be half wave, and that's generating about 30 volts, and then you drop the 5 volts or so, plus a diode drop of a volt, so you get 24 volts on the relay, to the relay. The relay only sees 22.5 because of the Darlington and the SCR. If I ever said triac in the past, I meant SCR drop on the timer circuit. So what's this lamp circuit coming up to? So I took a lamp out and I measured it, hooked up some wires, clip leads, and measured it. So it's a Model 327 lamp, and it's 28 volts, rated 28 volts at 40 milliamps, which is 1.1 watts, and works out to about 700 ohms impedance, resistance, whatever. It's kind of a DC AC thing. It works out to about 34 milliamps per bulb with a 23 volt drop across each bulb. So that's 800 milliwatts per bulb. You have 8 of those, and the math works out to about 680 ohms resistance to 700, but it's close. So if I set my pot to full 5K, I end up going from 34 milliamps to 27 milliamps, and from 23 volts to 18 volts, which is about half watt, 500, from 800 milliwatts to 500 milliwatts. So they're a little bit dimmer, not a lot. One of the things you could do is, if you're repairing one of these or got it open, you could change the Zener diode from 30 volts to 24 volts. But that would be, and you get about the same thing, somewhere in the 500 milliwatt range, about the same as the pot. But realize that whenever you decrease the bulb power, you're going to increase the dissipation on the transistor regulator. So if you reduce the bulb, you increase it over here. So you end up, instead of, this thing's dissipating about 2 watts. The way it is. So you have 8 of these. In a sense, you have an extra 2 watts here. So that's a lot of heat. I guess they don't like cold days. It helps keep the thing going. But this will go up to like 2 3/4, 2.75 to 3 watts if you change the Zener diode. With mine, it does about the same thing, about 2.7 watts if I turn this to 5K. So it's a compromise, But if you do LEDs, at least if you go back over the information I just said, which you can't read here, this thing doesn't focus for anything. But you probably want to use it. They have white and blue LEDs. They drop 3 volts or so. But you still probably want to run them about 10 mA. What you'd probably do is take these, take the LED, the lamp clips out, put LED with ballast resistors, run them about 10 mA, which would be like 2.2K, 2K, something in there, and but you need half-watt resistors. You need half-watt ballast resistors if you're going to run LEDs. And if you use maybe like a yellow LED, they make, you know, they make lamp holder LEDs that would retrofit into these, but the problem is they're like $4 or $5 a piece. So if you want to spend $50 on changing your lamps to LEDs, you know, be my guest. But I don't know about the polarity on those things either. So if they're bipolar by some chance, or you know, you stick them in there and they're the wrong polarity, they're not going to work, because you get this negative. This is never filtered. So it's always like this. It's just different amplitude over the bulb based on the transistor and that Zener diode. And if you, as you burn out bulbs, like I said, these regulator circuits, these emitter follower regulators, they're not that great with dynamic loads. So if you, as the LEDs burn out, or the lamps burn out, they're going, or if you remove them, this voltage isn't going to regulate all that great. It's okay, but it'll change by half a volt, and the current's going to change too. So you could take a couple lamps out, save them for later, put a pot in. You could change the Zener diode to a 24K and put a 5K pot in, have some adjustability. But you got to be careful about starving the, when you turn this up, put more resistance in there, you're going to starve the Zener. It may not work great. Overall, it'll probably work anyways, but it's kind of a crazy circuit. I think there might be other ways to do that, but I think they're using this. The reason this is so big is because they're using, I think they're using the 40% winding on the transformer to power the bulbs. Which, yeah. So, also I seem to get a difference of, if I'm hooked up to the frame, I get a different voltage reading than if I'm hooked up to the board ground where the voltage is generated. But let me take a look at this. Oops, it's there. Where is it? Come on. Oh, shit, I have it on ohms. Dumb guy. So, there's 75 volts. It's 100%. Let's see what happens if I go here. Ooh. 44 volts at 40%, supposedly. I don't need 40% power. 40% voltage, and 75 volts. So it doesn't make 80 volts. Should, but it doesn't. Yeah. 44. So I was expecting it to be about 45 and 80. Yeah. Might be a little bit low line voltage. I suppose, you know, if you have 115 volts, you're going to get one thing. If you have 125 volts, you're going to get something else. So, yeah, line voltage makes a difference to a certain extent. And that's about the secret circuits and the lamp circuit that goes on in here. You know? Yeah. That's about all there is to it. Went over the schematic, went over the lamp circuit, relay start circuit, etc., etc. So, maybe I will turn this off and see you on the flip side.
The Grand Operation.